All right, here we go. So let's talk about what a function is. Let's go to example 2. Hopefully this works. There we go. Finally. Example 2. So there's going to be a series of questions like this. Let's watch. Hopefully you're taking notes. This is what they're going to ask you. There's a series of, 6 or 7 questions right at the beginning of the homework that looks kind of like this, all right? And so how do we do this? Well, what we can do is we can make a little chart. Remember that little XY chart when you were in, pre-algebra, algebra 1, something like that? When you first started graphing, you made a little chart, you put some numbers in, you figured out what the X, or you put some numbers in for X, figured out what the Y was, and then you graphed it, you plotted the points. Usually back then, you just got straight lines. You probably always got straight lines. Okay, now we're getting a little further ahead. We're in Algebra 2. I don't know if you did this or not, depending on how far you got, but in Algebra 2, you got some curved lines. Well, this is going to be a curved line right here. So let's put some numbers in. So what we need to do is this, though. We could keep it like this. Let's put some numbers in for X. So let's put in, now let's think about this. Could we put a negative in for X? Like if I put a -1 in for X. I don't know if that's the best way to do it. Let's not think of it that way. Let's just do it like I was going to originally do, okay? I changed my mind again. So what we want to do is we don't want to have the X by itself. When we do these, we always want Y equals something, all right? So do we have Y equals something right now? Not really. We have Y what? Y squared equals, right. So we don't have just plain old Y equals. So let's get Y by itself, okay? So let's get rid of that square. Do you remember how to get rid of a square? No, you're not going to divide. What's the opposite of squaring something? Taking the square root of it. That's right. Okay, we're going to take the square root of it. So if I take the square root of this side, I got to take the square root of this side. Now, I'm not going to get into this, but there's a thing when you take the square root, you're going to use a plus and a negative, plus and minus. I don't know if you saw that before. Maybe some other day we'll talk about why it's plus and minus. Right now we're not going to, because that's not really what we're trying to do in this lesson, all right? So what we do is the square root of Y squared is just Y, so we got Y by itself. This is going to be plus or minus the square root of X. Again, don't concern yourself too much about the plus or minus thing. That's not really what we're trying to learn today, right? But just realize that it is going to be a plus or minus. So now what we can do is we can put in some values for X and figure out what the Y is going to be. Now we're going to go to that question that I had asked earlier. Can we put a negative in for X? Could we put like a -1 in for X? Well, let's do this. Well, what's the square root of -1? What number times itself is equal to -1? Is it? -1 times -1 is what? It's positive 1. But then it's not multiplied by itself then. If you go -1 times 1, it's not a number times itself. You can't. Why, Alex? That's right. When you multiply two negatives, all right, which would be the same two numbers, right? -1 times -1, for instance. That would be a what? That'd be a positive 1. Is that a positive 1? No. All right? It doesn't exist. And maybe, depending on how far we get in this book, maybe we're going to learn some things later on called imaginary numbers. Did you do that in Algebra 2? I don't know if you did that or not. Imaginary, the letter I, did you use the letter I? Did you? I is equal to the square root of -1. Do you remember that in Algebra 2? Maybe, maybe not. Okay, it doesn't matter because, again, that's not really part of this lesson. Okay, I'm just going off on a tangent here, so don't worry about that. But can you put a negative in for X, like -4? What's the square root of -4? There's nothing, right? There's no number times itself that's equal to -4. You follow me? Some people might say, oh yeah, -2, that works. But -2 times -2 is what? It's +4, not -4. What about a +4? What's +4 times +4? That's also a +4. It's not negative. So you cannot take two numbers that are exactly the same, multiply them together and get a negative answer out of it. Won't work, okay? So you can't put any negative numbers in for this. So what's the smallest number do you think that I could put in for x? Smaller than that? 0. You could put a 0 in for x, all right? What's the square root of 0? What times itself is equal to 0? 0, so that works. Now, there's no plus or minus to a 0, so we just leave it 0. So what's another number that I can take the square root of and come out to a nice whole number? 1. Let's put a positive 1 in there. What's the square root of 1? What times itself is positive 1? 1 is. But remember this thing right here? And you might be asking yourself, what in the world is that doing? Again, it's not part of this lesson. So we just understand that we're going to get a plus version and a negative version out of it. So when I put a 1 in there, I get a positive 1, and I also get a what? A negative 1. Whoops, made that a little too big. All right, because of that plus or minus. So if I put a 1 in for x, what's the square root of 1? It's 1. There's a positive 1 and also a what? A negative 1 because of that plus or minus. All right, let's keep going. I'm not going to put a 2 in there because what's the square root of 2? It comes out to some crazy decimal. Square root of 3 comes out to a decimal. What's the next number that would, if I take the square root of it, it'd come out to a nice whole number? 4. That's right. Let's put a 4 in for this. I'm going somewhere with this, believe me. We'll do 2 more numbers. So what is the square root of 4? It's 2. But also a plus and a what? And a minus 2, right? So I got a 4 that goes to 2 and it goes to negative 2. What's the next number that I can take the square root of that comes out to nice even number, nice whole number, I should say? 9, right? 9 would be the next one, right? Because square root of 5, nope. Square root of 6, I can't do it. Square root of 7, I can't. Square root of 8, I can't. Square root of 9, yep. I can take the square root of it and it comes out to what? 3. And also what? Since you got that plus or minus out in front, a negative 3. So if I was to graph this, I don't think we got to this the last time we did this lesson. I'll tell you what, before we even graph it, let's do this. I have the lesson, it's up on YouTube, on the part A part, okay? It just says 2, 4. But the thing that makes it a function is that each x can only go to one y. But look at this x. This 1 goes to a 1, and it also goes to what? To a negative 1. This 4, it goes to what? A 2 and a negative 2. This 9, it goes to a what? 3 and a negative 3. Anytime you have one x value and it goes to more than one y value, that is not a function. So what was the question? The question seems to be a pretty simple question. Is this a function? So really, what's my answer then? Remember, if it's a function, each x can only go to one y value. But look, this goes to two y values. This one goes to 2. This one goes to 2. So is this a function then? No. It's not a function. All right, because one x goes to two different, you get two answers, right, for that one x. That means it's not a function. You can only, to be a function, one x can only have one y. You hear me? It's important. This is something that you learn in college, you learn in upper level math, not really that upper level, Algebra 2 kind of math, pre-calc kind of math, and in here, in college algebra. All right, so this is not a function, but what I want to do is I want to graph this thing and just show you what it's going to look like, and I'm going to show you another way to figure out if it's a function or not. Actually, let me just keep this white. Let's put some numbers on here. So what are my x goes to? It goes from 0 to 9, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It keeps on going, but we'll just put it there. There's 1, 2, 3, there's 4, and we'll put those in there. Of course, this is 0. So let's plot some points. 0, 0. So let's use a different color for that, like I was going to earlier. So we'll put a dot right there. What we're going to do is we're going to graph this. This may be the first time you've ever graphed a curved line. I don't know. By the sounds of it, it sounds like this might be. So what's my 1 going to go to? It goes to positive 1, and it also goes to what? Negative 1. So 1 for the x, it goes 1 for the y, and it also goes where? Negative 1. Now, that's really not enough to be able to graph this correctly because it looks like maybe the line just goes straight out here and straight out here. Okay, but let's put another one in. Let's put in 4. 4 goes how far up? It goes up to what? 2. And it goes down to 2. To -2. What about 9? How far does 9 go up? 9 goes to what? 3 and -3. See, it goes up here like this, and it goes down here like this. It looks like it might be a straight line, but really it's not, is it? Look, if I connect that and that, these two aren't on that line. So it's not a straight line. It's actually a curved line. So it starts here, and it kind of curves. Doing it by hand, especially on this thing, makes it kind of tough. And then this curves like this. If I can continue it. Nope, I can't continue it. Let's try this again. Just put it right there. There we go. All right. So it's kind of ugly, but that's what it looks like. So it's a curve. It's not a straight line. Has anybody graphed a curve before? Did you do that in your other math classes? Okay. So you have done this. Now that's what the graph of this looks like. Now, if I was just to give you some graphs, which I don't think they do here, but if I was just going to give you some graphs, you should be able to tell very easily if that thing is a function or not a function. And we know that it's a function or not a function by a thing called the vertical line test. I'll just write it down. I won't write like exactly. I have it in my notes. That's right. So if I drew a vertical line, it's called the vertical line test. And what the vertical line test basically says, and I have it written down, but I'm not going to write it down for you just for time, says if we draw any vertical line that intersects the graph more than once, then the graph is not a function. So if I was to draw a vertical line anywhere that touches that graph, okay, let's say right here, okay, how many points does it touch that graph? Twice. It hits right here and it hits right here. Okay, if I draw a vertical line here, it hits right here. Whoops. It hits right here and it hits right here. So if it hits twice, what did we say about it? It's what? Not a function. Okay. Now we could draw it right here where it only hits. Whoops, I did that in yellow. I should have done that in red. Let's make that red so it stands out a little bit. There we go. All right. And you say, well, wait a minute, I drew a vertical line right there at 0 and it only hits the 0. So it only hits at one spot. So it's a function. No, it's not. It's got to be able to hit anywhere on that graph. Okay? Anywhere on that graph. In order to be a function, it can only hit that graph one time, the vertical line. Right? But it hits here twice and it hits here twice. Anywhere else you put a vertical line, it's always going to hit twice. So with all that said, it's a simple answer, but it takes some doing to figure out why that answer is what it is. So is this a function? No, it's not a function. Now you're going to have to tell me why. If this is a quiz or a test, you're not just going to be able to say yes, no, yes, yes, no. You're not going to be able to do that. You have to show me why it's not a function. One way would be to graph it. Another way would just be to do your little chart right here and just to show me that one x goes to two different y's. If you have that situation, then it's not a function. All right, let's do another one. I know you're excited about this. I've already knocked out about 5 or 6 of you. So it's probably not a good thing, but that's all right. So what about this right here? This kind of looks the same, but it's different. If I can get my marker here. There we go. If y equals x squared a function. Now that's different. What did the other one say originally? Y squared equals x, right? But this one I got y by itself, so I don't have to get y by itself. It's already by itself. I got to figure out, is this a function or not? Well, let's do this. I'm going to graph it as well. You don't have to graph it, but I'm going to, because I'm going to show you that program. Remember that program that I told you? It's a really good graphing program. There's a bunch out there, but this is my favorite one. I'll show you how that works in a second. Yeah, that Desmos. Okay, I got it on my phone. It's an app on your phone. Doesn't cost anything. It's a great graphing program. It's super easy. Way better than like the TI 80 whatevers to graph. It's so much easier. So anyway, let's put some numbers in. Now this time, can I put negatives in this time? Can I put a negative in for x? Yeah, because what am I doing to that negative? I'm just squaring it. Am I allowed to square a negative? Yeah, absolutely. So let's not put in too many. Let's go -2 and then -1. I like to have a couple negatives and a couple positives, throw in 0, and let's see what I get. So what are my y's going to be? This is very simple now. It's a lot easier than the other one. So if I put a -2 in for x, remember I'm squaring the whole entire negative and the 2. So if I put a -2 in for this, I have to square it. So what's -2 squared? Anybody? -2 squared? It's nothing. -2 squared is nothing. If I take -2 and I square it, I multiply it by itself, what do I get? I get a 4. Right, if I'm squaring it, I multiply it by itself. So -2 times -2 is +4. It's not -4, it's +4 because it's negative times negative. In fact, what's the sign of every one of these y's going to be? It's always going to be positive because anytime I square something, I always get a positive number. Okay? Let's put -1 in for x. So what's -1 squared, or -1 times -1? That's what? +1. Let's put a 0 in for x. What's 0 squared? 0 times 0. It's just 0. Let's continue. Put a 1 in there. This time we're putting a +1. But it doesn't make any difference. You get the same answer. What's +1 squared? It's 1. Okay? Let's put a 2 in. 2 squared is 4, and so on. Now, we do see some repeats here. Does that mean it's not a function? Now, remember, every x can only have one y associated with it. This x right here, can you have any more than just a 4? No, you can't. You got one x associated, or one y associated with it. What about this one? You only get one answer, one answer, one answer, one answer. So what do you think this is then? This is a function. And that's what they're going to ask. Again, they give you a series of questions, I don't know, 6 or 7 of them, something like that, maybe 8, where they say, is this a function? Doing this right here is enough for me to show that it's a function. So is it a function? Yes, it's a function. So if it's a function, it should pass what? What test? What line test? No, not straight line. What is it? Vertical line test. It's got to pass the vertical line test. Not just any straight line, okay? It's got to be a vertical line. So what I'm going to do is I want to graph it. Okay, this is good. This is good practice for us to graph. So we've already done our little chart, so it shouldn't be that hard to graph. So let's make the y-axis and the x-axis, and let's put some points on here, -2. So as far as the x direction, we only go to -2, and we go to +2. On the y direction, we go to 4. 1, 2, 3, 4. 1, 2, 3. I could do this with graph paper, I guess. It would have been a little bit more accurate, but this is good enough. Because most of you guys probably aren't going to use graph paper anyway, so this is probably good to do. All right, let's put some numbers in here. -2, 4, some points, I should say. So -2, 4 would be right here. -1, 1. -1, 1 would be right there. Do we just draw a straight line since I got 2 points now? No, I need to see some more about this, okay? Because this is not just a straight line graph. 0, 0. That right there makes it not a straight line. Do you see it? So this one curves as well, but it curves a little bit differently. This is 1, 1, and this is 2, 4. And you could put more numbers on there if you wanted to, but we're just going to stop there. So this actually curves. It actually curves right here like this, and it just kind of follows that pattern like this, and it curves. Oh, don't have enough room on my... Oops. You get the idea. Oh, not that idea. Boom. There we go. It kind of looks like that. That's pretty bad. I was going to say it's pretty awful, but you get the idea of what it's supposed to look like. This is supposed to be a nice, smooth curve. All right, it's supposed to be anyway. So what are we trying to do, though? If they give you a graph, how do I know if it's a function or not? I got to see if it passes what? Vertical line test. It's the vertical line. So I should be able to draw a vertical line anywhere, and it only crosses that graph at how many points? 1 point. So if it only hits at 1 point, no matter where I put that vertical line, I could put that vertical line right down the middle. It still only hits that graph at 1 point. I could put a vertical line anywhere on here. It doesn't matter where I put it. It's only going to hit the graph at one particular point. So that right there means it's a function. Okay, that's the vertical line test. So I think that's pretty interesting to see. All right, that kind of finished up what we did earlier, but right now we're going to delve into a little bit more with functions. It looks a little complicated. It looks like it, but it's really not. I don't know if you remember the very first thing that we did on this lesson. Probably not. I don't either until I look at my notes. But we had, let's see, I'll just make one up. What we're going to do is very, very similar to this. What if I said y equals, 3x plus 2? Okay? And then I said, find y if these following things could be true. X equals, -1, b equals 2, c, I should have said this. I should have said x equals 2. Sorry about that. X equals 2, and then, x equals, let's say 0. All right? Remember we did this? We just plug stuff in, plug numbers in, and see what y is equal to. So if I stick a negative y in for this, what do I get? I get 3 times -1 plus 2. What's that? That's -3 plus 2. What's that? That's -1. So when x is -1, y is -1. It doesn't always happen that way. It just happened to on this one. Let's put a 2 in for x. So what do? We just plug it in, right? Substitution is all it is. So I've got 3 times 2 plus 2. 3 times 2 is 6, plus 2 is what? 8. Remember doing this? Put a 0 in for this. So it's what? 3 times 0 plus 2. That's 0 plus 2. That's what? 2. Very simple. What we're going to do right now is exactly what we just did. It's just substitution. It just looks different. It looks a lot different. Well, kind of different, I guess. Depends on what your version of a lot is. So keep that in mind. Keep that substitution in mind, because what we're doing here, to tell you the truth, I don't think I did this stuff until I was in college. My first class, I took like a pre-calc class in college. They talked about functions. I was like, whoa, I didn't do functions when I was in high school. I'd never seen that before. So the first time I ever saw this stuff was in college. So now you get a little head start, at least a little more of a head start than I did. So the first thing is, this is called function notation. And the first thing, instead of writing y equals whatever it was, 3x plus 2 or whatever the thing said, what we're going to do is we're going to use this notation right here. It looks like it's f times x, but that's not what it is. This is f, this is how you say it. I'm going to put it in quotations. We say f of x. All right, that's what that means right there, f of x. Everybody see it? 1, 2, 3, 4. Wow. Sam, you win. You're the only person in this row that's got their head up and paying attention. All right. So this is called f of x. This is that notation. So anytime you see this, it doesn't mean f times x. It just means f of x, the function of x. Okay, that's what the f stands for, is function. It's the function of x. So instead of seeing this, instead of seeing, I don't know, just making this up, instead of seeing this, what do you think it's going to look like now? Instead of y equals, what are we going to replace that y with? Come on. Somebody's got to see it. F of x, that's right. Because it says right here, right? Y and f of x are going to mean the same thing. But we're just not going to put a y. We're going to put f of x. I know, it seems weird, seems confusing. It's like, why would they do that? Why? They're just trying to make it harder for us. And I kind of feel your pain a little bit on this. But there are reasons a little bit later on why they do it. Okay, but at first you don't really see it. So instead of y equals 4x plus 3, how are we going to write it? F of x equals 4x plus 3. That's all we do. We just replace that y with an f of x. All right? Now, it doesn't always have to be f. It could be other letters as well. All right? Sometimes they use g of x or h of x. Usually those three they kind of stick with, f, g, and h. But f of x is very, very common, and that's what they're going to do. So they mean the same thing. So with all that said, I'll show you how easy this is. Here's what they ask you to do. This is example 3. This is right in the book. It's example 3. It says, let whoops, got ahead of myself. Let f of x equals 4x plus 3. Okay? There's your little equation they're going to give you. And now they're going to ask you to find some things. Now, again, this notation's a little different. Over here, what did I say? I said find y if x equals negative 2, if x equals 2, if x equals 0. Then all I did was just plug it in. Agreed? I'm going to do the exact same thing to this, except I'm not going to say if x is equal to. Okay? What they do, they say find, this is part A. There's 4 parts to this. This is part A. They say find f of 3. That's how they say it. Instead of saying if x is equal to 3, they say find f of 3, which means what are you doing? You're just basically taking that 3 and putting it in for what? For x. That's right. And so that means you're going to take that 3 and put it in for this x right there. It's the same exact thing as we did before. It's just the notation is different. It just looks a lot different. Oh, I thought this went till 1 o'clock. All right, well, let's do this one problem and we'll be done, okay? So how do I find f of 3? I just go 4 times what? 3 plus 3, and then you work that out. That's 12 plus 3, and that's 15. That's your answer right there. That's all there is to it. We'll do a few more of those, and then I'll give you homework tomorrow, okay? No homework tonight.